Hello, Alan.
Good morning, Howard. Okay, good morning, everybody. Welcome to the OCP HPC subproject meeting on March the 4th, 2025. So today I wanted to discuss, carry on discussing the interconnect. I've had a few bits of correspondence with Lotz and Amphenol, so thanks, guys. But I guess I'm getting myself a little bit confused. So I wanted to pull all the pieces together, hopefully today, and actually really get maybe we can nail down this universal topology interconnect, and just get to the bottom of some of the cable discussions we've been having and the options going forward. So let me share my screen. Excuse me. Okay, hopefully you can see that. Yes. Yeah. All right. First of all, I think we've got a new member. Come on. I can get myself organized there. So Boon Chong Ang, would you mind giving a brief introduction to the group as what we normally do?
Hi, I'm Don John from Intel. I just trying to understand what is this HPC all about. Thank you.
And what does you do with Intel, Boon Chong?
Two-flow methodology related, the technology enablement and two-flow methodology.
Sorry, can you say that again? I missed that.
The technology enablement and two-flow methodology development.
Technology and development.
Yeah.
Okay. Well, welcome aboard. Everyone, welcome. Okay, so really the main subject of today is the MCIO connector discussion, as I said. Oh, just a couple of our updates. Our abstract did get accepted for the OCP Regional Summit, so I'll be giving that. And I did, because it's the end, because February is now come and gone, I did reach out to the New Frontiers team with regards to our proposal response. I've not heard back from them yet, but technically, I guess they should have awarded it by now, but I'm sure with all the new administration and all that, that's delaying things. So I'll let you know as soon as I've got a reply back from them. So on the interconnect, yeah, there's been a few things popping around, so a discussion's going. So I wanted to try and, like I said, as much as anything, get my head squared away. So I've just quickly redrafted this presentation together, and I can also take some notes in it with any answers from the discussion today. So first of all, this is the slide we've had from age old, is what is the reason for this topology interconnect solution? What are the goals? We've now chosen the MCIO as it stands right now, and the next generations of it. And we've got all of these, right? So everyone on this call pretty much is aware of it, of all of the things we're trying to do with this. So I won't regurgitate that. Also, so obviously one of the features was removing the through-hole features of it. So that was that discussion, which we've been working on. I had a preliminary pinout proposal, which Amphenol and Lotz proposed an updated pinout to be more like the standard MCIO. So I need to update that table specifically, and I'll come on to that a little bit later. We are also looking at the capability of having this active cable thermal interconnect for cold plate, for mating to cold plates. And now getting on to the meat of the discussions I've been having with Lobson and Amphenol. First of all, so this is a recent email from Howard, you and your team. And I just summarized it here. So you're sending a cable to me, but this is a PCI Gen 6 cable. So you noted that it's 26 gauge, so quite a thick cable. The raw cable thickness you said is 2 millimeters. So first of all, can you confirm that's two twin axes on top of each other like this, like in this picture here?
Alan, this area, that should be 29 instead of 26.
29. Okay.
Yeah.
That's a good
And then
start.
that's basically two ribbon strips.
So 2 strips is 2 millimeters.
It's 2 millimeters, yeah.
Okay. And you said you need tooling to bend close to the connector. So I guess that's a special tooling that you'd need to do to give us a nice tight bend like this.
Yes.
And the inner bend diameter, your people back in engineering are saying that 4 times the cable thickness. So so if this is 45 degrees, that should be 45 degrees. Anyway, I'll sort it out later. 45-degree bent cable would be 2 millimeters plus 8 millimeters plus 2 millimeters equals 12 millimeters. Is that right? Or have I got that wrong? Because it's 2 cables, should this be 4? Should this 4 times cable thickness be 4 times 1 millimeter or 4 times 2 millimeters?
Well, since that's about 2 millimeters for the 2 strips times 2,
Right.
that would be 8. Yeah.
So right, so it's not the thickness of an individual strip, the 4 times cable thickness.
Yes.
Of a single.
Yeah, go ahead, please.
Yeah, Rio, I think the if you look at the just one cable, right?
Mm-hmm.
So the radius, or you can use the diameter. So diameter is 4 times the cable, right? So if we bend the first one, that is 4 times 1 millimeter, right? Actually,
Right.
is 4 millimeter. And since we bend the first one like that, and the second one it's on top of it, right? It's already meet the 4 times cable thickness. So I will say it's the first cable bend radius diameter, maybe say the 4 millimeter, and plus the first cable thickness is 1 millimeter. Then the second cable is on top of it, right? So it's another 1 millimeter.
Right.
I will say like 6 millimeters. That's I think. So the 2 millimeter is the 2 cables, right? The one on the on the top of another one, right?
Yeah. So
Can you say
yes. So
sorry, so when you're saying the 4 millimeter diameter, that's to the center of the cable, or is it to the outside? Is it to the outside of the cable? I guess that's to the center of it. Is that what you're coming? Because if I make the middle 4, like you're saying, Z, then 2 plus 4 plus 4 is 8, and you just said 6.
Yeah, usually. So yeah, it's maybe a little bit different from we call the inner radius. I think band radius. So I think those called the the inner band diameter. So if say the diameter, basically the radius is half, right? That's my understanding.
Yes,
Yeah,
yes,
yeah,
you
yeah.
got that.
Yeah, the radius is half. So that means, yeah, so if you've got if the cables are folded on each other, that would be 4 millimeters gap. And if it's the inner diameter, not the centers, then that is my equation right here. 2 millimeters plus 4 plus 2. For this bend here, if we measure across this bend here, that will be 8 millimeters based on what you're saying. See?
Yeah, I think what we're seeing here is 2 millimeters for 2 cables, 4 millimeters for the airspace between or diameter, plus 2 millimeters for 2 cables, and 8 is correct.
Z, you said 6. So what were you missing there?
Yeah. So I didn't count the a second one. So it's you actually bend 180
Yes,
degree.
see.
Yeah. So it's
Yes, it's
you added
180.
another 2. Yeah, that's correct. Yeah.
Yeah. 2 times 1 millimeter thick, 4 millimeter diameter, 2 times 1 millimeter thick, 8. Whether it's
All right.
45 or 180, it's still going to add up to 8.
And this is good for Gen 6. And you were saying about Gen 7, you would need to be maybe even bigger radius, right? See?
Or would the finer gauge of the Gen 7, smaller than 29, give us a little bit tighter bend? We could, I mean, not much. It would probably not even get us down to 7.
Actually, that's a good conversation, Howard. Let's hold that thought and don't forget it.
Okay.
I'd like to come on to that maybe as a separate topic, and let's do a separate slide on that. But that's a good point. I basically want to work with what we've got here right now. So actually, guys, on these cables, with the loss budget of the 29 gauge and Gen 6 speeds, what cable lengths are we sort of designing to? You know, what's a maximum length cable that you can make with this configuration and comply to loss budgets, I guess?
Well, this sample is measured at, I mean, this cable that shown here is 500 millimeter long.
So, okay.
Yes, I think the certainly based on the topology, right? It's
Yes.
the channels also need to include the PCB, the trace length, but usually,
fair point.
yeah, the inner, the internal cable can be 1 meter long. The top side.
Internal cable 1 meter long. But obviously depends on ends as well. PCB basis, etc. Okay. Yeah, is that fair? But you're saying 1 meter is the longest cable you guys make, yeah? Internal.
I mean in the PCIe spec, right? PCI 6 spec.
Oh, says it needs to be 1 meter.
That 1 meter is the longest. Yeah, we quoted there, but yeah, the individual case can be vary, right? Depends on the trace length package, the how powerful the driver is. So yeah, the PCI SIG standardization is around the 1 meter is the longest one. Yeah.
Okay, all right, that's good then. So that's good to work with. So
So maybe, yeah, I'm not sure. You put the title is the loads of the PCI 6 like MCIO cable. Maybe you just remove the loads, just to say the PCI
Yeah,
Gen 6
I
MCIO cable.
guess. Yeah, well, I guess if you're both in agreement, then that this slide is applies to both of you. Then fine. Yeah. Well, I've got a separate slide for you as well. See,
Okay, yeah, we have,
it's
yeah,
just these separate email
slightly
conversations.
different probably, yeah. So okay, yeah, I now I understand where you're going. Yeah.
Yeah. So and all I'm doing is I really just dumped the data that I got out of your emails to get it into one place. So from your perspective, you were talking about what's the minimum cable length we can do, because we had that discussion. So you said 50 millimeters, which is good. But then you said the molding is 7.1, so at both ends, that means really our minimum length is 64.2. I'm assuming that's center to center of the connector. Is that right, or is that correct, or is it is it including the entire connector body? Is 7.1 millimeters?
Yeah, that's the center to center, the center of the mating interface, right?
Okay, the center of the main interface, right? Okay, I
Yeah,
got that.
yeah,
Right. Good. Thanks for that clarification.
Mm.
You also said the model that you shared was 30 gauge, about 0.9 millimeter thick.
Yeah.
So that's as opposed to Lotz's 29. And I think you mentioned 29 or 30 as well, didn't you? Or
Yeah, we do both as well. Yeah, and yeah, the 29 is a little bit thicker, right? So yeah.
right. So on the 29, on the 30, does this pretty much still apply? Is it hardly any difference, or is there a significant difference in this?
I'd like to speak up here for a second, and I was thinking about a 1 millimeter thick for the cable. And if you look up here, it says the raw cable thickness is 2. So I think we need to go back and look at our formula
Yeah,
here.
but that's two twin axes on top of each other.
I think it's 4 for two
Okay.
twin axes, because I just heard Z say that a 30 gauge or 29 gauge is 0.9 thick. So there's point I think we need to clarify how thick these cables are. Shielded, insulated, everything.
Right. So
Is it
actually
1
we
or is
can.
it 2?
I'll tell you what. This is probably a good time to jump to the models. So here's the models that you guys have sent me.
Perfect.
So this one on the right here is what you sent me, Howard.
Yeah.
You sent me the two pieces, and you sent me one fully assembled piece. And thank you. You've done the surface mount, like we were discussing, except for we don't have the left hand, right hand that we were discussing. So
No, I don't think that's holding anything up.
what do you mean? Holding anything?
It's still going to take up we still have a 0.3 cap.
Oh yeah,
cap.
no, for sure. I thought okay, but it is possible, and you can do it, right? So
Yeah,
it's not
that's
okay.
just a stamping thing.
Okay, good. Yeah. So
Can you do a
this
measure
is.
for that cable?
So yeah, I did do a measure for the cable. So your cable, and I don't know if this model is representative of your 29 gauge but an individual cable is 1.04 thick in this sense.
Okay, so 1 thick.
And then you obviously have a gap between them, but you can. I'm assuming we can compress that gap.
Yeah, as soon as it goes around the bend, it's going to go tight against each
But
other.
that's 2.505. So yeah, I mean, it looks like 2 millimeters is
Okay,
correct if this is.
I just don't want to have things move forward and not be right. Thanks.
All right. And then on the other thing we were discussing was height. Sorry, not that.
Go right up to that.
So you're at the 9.18. Is that right? That's low profile, man. Is that what you said? Does that add up? I do remember you saying in one of your emails, actually, Howard.
I'm looking at the numbers. Looks like 1103, 2 faces on the
That's
text.
close to it, yeah.
The height. Oh, hang on a minute. Have I got? Hang on. That's a good point, actually. Let me just reorientate myself to make sure I've got the right Z. Yeah, so Z is up and down. So that's 9.18.
Oh, which way Z is?
I think this is Z. Yeah, because this one is going to be the long. No, that's 23. Oh no, it's actually between the things I highlight. I'll tell you
Yeah,
what, let me get a center pin here. If I get a center pin, be sure we know we're looking at the right number.
to the tape.
I do this.
And that measures
Oh, 11.06. Thank you.
1106.
That's a y dimension, not a Z dimension. So Z is in the page. All right, fair enough. 11.06. Right, okay. So actually, let's just throw that in there. Actually, I might make this back to lopes because there are generics in there, but there are also specifics in there. So let me just sort of throw in there. Low profile height equals, I just call it 11 millimeters, round numbers.
Yeah.
All right. Okay, good. Going back to the model and looking at these ones. So the one you sent me, Z, is this one just recently. And this one, I think when I've seen your models before, that's 2.1569. So okay, so that is right. So this is your 30 gauge version, I'm assuming.
Yeah.
So you've got it as so you've just got it around 1 in the model. Is that just for simplicity's sake?
Yeah, just simplify. But yeah, second is there, yeah.
One thing I did notice when you bundle them into a round cable as well, I noticed that your diameter of your models of the bundled round cable on a by 16 and a by 8 were identical when you've got twice as many cables. So so it would be good if you could ask your modeling people to make it sort of representative. It would be helpful for us trying to do some space planning. All right, so now you've made this surface mount as well. You've gone slightly different. You've added additional feet here. I'm not sure if that's going to cause us any issues, and probably not a bad idea for balance purposes.
Yeah, so we think when those through hole removed, you need some stress relief, right? So for the solid joints. So
Yeah,
so that's we
for pulling on the cable, especially as hard as we're going to be bending this thing. That gives us some torque support.
Yeah. So I'm not objecting to any of that as long as it works in terms of centering everything. The only thing we are going to do is we're hopefully, well, we are we're going to, with this foot. So this foot should be 3 millimeters if we from what we discussed. Hopefully it's not
1.5. What does it say? 165, and it's buried.
Yeah. So in fact, we do need to. So we need to make that. In fact, there you go. So from there, I think there to there is 1.4. So I think what we were wanting to do was we were wanting to make that 3 millimeters, and then a left and a right.
Yeah, but if we're looking at the surface area, which is what is going to give us the retention, It doesn't make any difference because I've got to cut away half of this foot anyway in order to take the left hand part.
Right. But for my model, I need to. So we're gonna put a stiffening frame that will land on these feet.
Yeah.
And so
But
there's.
still, even if it lands on those feet, the applying a torque to that is going to be thousandths of an inch that in order to break the solder joint. And the hole that Z is shown here gives a well for the solder to wick into. So, I mean, there's some nice features here with this additional foot and the holes through give it a nice.
Oh, and actually, and I see that you've actually done it left and right. You've done it left and right-handed, have you? No, you haven't.
No, they're right down the middle. Those on that
Well, not exactly
they
right down the
bump
middle.
into each other.
They do bump into each other, but they're not right down the middle. So is there any way that we can make these? I mean, these look smaller. It looks like we could put another foot on here. So could we put this one down there and then that one up there? And then how long have you made this, Z? Let's have a look at this one. You've made it 1.7 as well.
Yeah.
So, I mean, if we could make that 3 millimeters,
Then
again, I don't mind you.
you'd end up with a smaller foot offset, though if I don't know whether they would help each other or not, depending upon how they're lined up.
Well, so you say a smaller foot. We've got this at the moment. This foot is coming from here to here,
Right.
And then you've got this piece at the bottom. I don't know if that dimension there is exactly the same. Hang on a minute. Let's do from there to there. It's 2 millimeters, right? And then from here to here is 1.64. So you'd have to make it 1.8 or something, 1.8 millimeters instead of the 2, and then do a left and a right hand.
But do you know what I'm saying? If I put a right hand and a left hand together, I've got to remove material in order for that hand to come up close. Okay, I'm going to draw a picture.
Oops, sorry. You drawing?
Yeah, I'm drawing in paint on my.
I see. I mean, it looks like this one isn't too far off. I don't know what I'm missing here.
So, Alan, what's the purpose you want to extend the that leg?
Geez, man. I'd need to load the other model in, and we'd have to wait 5 minutes for the model to load. If you remember, we had a stiffening frame on the module. Tell you what, there you go.
Yeah, so you try think your stiffener can press that leg down.
That would be the idea. Well, it would still be soldered down for sure, but it would be it give you an additional mechanical holding of that leg. Yes.
Yeah, I'm not sure that really helps.
You don't think?
You will not add a huge force, right, to against that leg. And
Right.
also the leg has a solder bump there, and means probably not that even. So you are land on a solder bump. It's like a small hill, right? Hilltop, basically your stiffener.
Right. I guess it depends on how much solder paste. Whether you should get, if you've got a fillet, it's just if you've got too much solder, then obviously it might overfill for sure.
Yeah.
Alan, let me share.
Okay. A minute. There you go.
I gotta see how to do this. Share. So if we have 3 inches, 3 millimeters here, between here and here is 3, right?
Right.
So we have a 1.5 by 1.5 square, and the same thing here. Well, call it 3. If we do straight lines here, we end up with the same total solder surface area.
Right. So I understand that. Yeah, agreed.
So this area here for retention and this area here for retention are the same area. Now,
Right.
they'll get a little bit of lever arm, maybe advantage here, but we also have removed all of this. Where's just a pencil? All of this area, right? We just cut away in order to extend this foot. We've cut away all this portion of the foot.
Right. When it was a
So we
wider
have
foot.
no additional surface area added.
No.
So I would prefer that we make a straight, plain old foot here.
Right. Hey, by the way, it was you, Howard, that suggested the left and right
I
foot.
know, and I disagree with myself.
I
Yeah.
thought it was a great idea, personally.
So
I hear everything you're saying, and I completely agree. But the longer foot then gives us that extra area for us to land the stiffening plate onto. The stiffening plate is not going to be able to land onto a 1.6 millimeter foot. So therefore, you'd land on both the left and the right-hand foot of the two connectors.
so we'd end up with that.
Otherwise, we make
Here's
them.
the stiffening plate would pass through here, right?
That's the idea.
Going
Yes.
this way,
Yes.
and it would
So
just this top surface area is what you were concerned about.
so it would land on top of that top surface area.
Yeah.
Yeah. That was the logic, anyway.
Here's my concern, that there will be some space between here and here, right?
Right.
I don't know, 0.1 or a couple thousandths, and because this plate here that is huge compared to this little tiny space.
Yeah.
And so there will be a gap in here guaranteed, right? Between the bottom of this as it comes through, that this really will not be holding these feet down at all.
Unless you have some compliant material at the bottom that does give you a compression force, but not obviously as much as if you bolted it hard to hard.
Yeah, I don't believe that it's really going to touch 80% of the time. It is going to touch 20% of them. And
No, it's just saying, well, if you put some sort of compliant gap pad, which would compress, so it would definitely touch and compress.
even if you do, it's still only going to be 80-20. Because the amount of force that's going to be per module is going to be a lot. So
I guess is what compression force you're going to get from, because the heatsink's shore is going to be bolted to the entire board, right? So there's going to be a number of things bolted to the board. The board's going to flex where
yes,
it's not bolted, and so your point is valid on where it flexes.
yeah, this cooling channel is going to be a huge chunk. And these things are teeny tiny.
Right.
And so the opportunity for there to be an airspace in here, or say some thermal compound, right? It's going to squeeze away, and if things flex a little bit, there's going to be
It wouldn't be it's not for thermal purposes, it was for mechanical purposes. So
yeah,
to give it some additional holding it in place. So you're
yeah.
saying that's not going to work.
Z, do you have a comment?
Yeah, that was a comment I made before you show the drawing, right? So I have the same idea as you. That mechanism will not work.
Okay.
So basically, you only can be able to touch a few top points.
I
That's
think
it.
the little foot that you put over here is this foot that you put on is a much better solution to deal with the amount of force that's going to get on this thing when they yank the cable around.
Yeah, so I think the stiffener press down on the solder leg is not going to work because it will not press down the solder leg. Basically,
Yeah.
it's not even. The solder bump is not even, right? So you only be able to press maybe 2, 3, I think the 3 or 4, maybe a little bit more than the points, but it
Yeah.
will
Even
not
with
touch
solder,
everyone. Yeah.
the the board that lays under here, they're going to tip left and right a little bit. So things are going to get misaligned where this, the solder will wick one way or the other.
Right.
You're not, oh, maybe this is going to be like this, a little bit closer. But
Right.
there's this surface is not a nice thing to control. All we really care about are that these make a good electrical connection down the length of the connector on the surface feet. These guys.
Right. Right.
And where this foot occurs is not only not a component of this, it's sort of sleeved on. It's yeah, it's attached, but it's there to absorb the force of yanking on the cable, which we're really going to do.
No, I don't disagree with the yanking on the cable. It's not that is my concern. Do you think that'd be good enough though? Surface mount pads, because they not get like, and my experience, like micro USB. If you remember micro USB in its day, it was purely a surface mount thing. But we would tear those bloody things off the boards all day long.
Yeah, it's true. Yeah.
Um,
Yeah,
so
losing our tabs and pegs and all that. Yeah, they're there for alignment, but they also do a little bit of reacting to the force of, whatever. So I think our square millimeter of space is the most important thing here. How sharp this corner is probably going to be a component of how well this holds it down. But I also think that the addition of this extra solder tab that Z has on his design is great. And I'm gonna have to go to Ariel and say, can we do this with our existing shield?
so what about all right.
Okay, I'm gonna
Yeah,
unshield.
so I've no objections to the additional ones. I don't see that being an issue at all personally. So as many additional ones as you want to add is fine. I guess just from a soldering in a sort of the pad alignment that we were talking about, they float. You get the capillary attraction, with the pad size. We obviously want a sort of a self alignment with the surface mount connector if possible.
Yeah, the only thing we have now is surface tension.
Right, right. And I guess the more of these big pads you put on, does that help the surface tension alignment or does that hinder it?
I don't know. There's probably more square inches of this space square, of these guys, the pads.
Right. I mean, that's where you want to get the alignment, and you want the pad size design would need to be critical, right? To
Yeah.
get. Okay. All right. Well,
Okay, I'm going to turn this
So
over
what
to
we're
you.
saying then is a left and a right hand is not a good idea at all.
But
The
it does
stiffness-
make things simpler, but it also, the addition of this guy is, I think, a great, if we have capability of doing that, I think we should make sure there's a pad there for that. But
there's no point putting making the left and right to make it land.
I really don't think so. And we're stealing a little bit of airspace in between.
I think left right thing it's maybe able to do. Howard, I'm not sure. I didn't or I don't see the maybe big issue with left right kind of design.
No, I don't think there's a real issue with it. I just realized
Yeah.
that it didn't help us.
The foot gets long,
Um,
it's 3 millimeters long instead of
Yeah, no.
the only thing that in my mind, and again, I'm not a mechanical engineer, but it's just whether if there is not a thermal gap pad, but in the concept of a thermal gap pad, some sort of compliant plastic sort of shim that you could put that is slightly compressible, but would give you a mechanical force. You know, so if this stiffener is heavily bolted to the board. and obviously the board will flex, but if in these particular areas we design it to land and we have some sort of compliant shim that will give some mechanical strength, okay, it might not work, but if we don't put the left and right hand feet in, I've got nothing to even try it. So if I've got the left and right hand feet, at least we can I can get somebody to do some mechanical simulations about, does this give us any stress relief at all with like a shim of some sort, a compliant shim of some sort.
Yeah, I don't have an issue with bending that part that way. And like Z said, we can do it. And the comment that you made that the reason to do it is to give a surface for this part.
Yeah.
My thought was that it was really a surface tension ability to hold the connector from getting pulled off the board.
Yeah, no. So adding all the extra ones, if we can do the left and right hand and make them 3 millimeters from the outside body, I mean, basically Z's connector almost already does have a right and left hand. The size he's made it, but obviously they're both on the same side, so it doesn't work right and left hand. But so if you could modify that, Z, maybe that'll be the way forward. At least it keeps the option open. I'd certainly hear you that this is not going to work just with the stiffening plate, but I wouldn't mind just exploring some options if the foot was there for us to land on. So if we can have a foot to land on, that would be a bonus. Is that okay?
So I think yeah. So maybe Alan, what if you want going to do the further study? Put that in your mind is the foot. It's not even. One foot may be higher than others after the solder referral. So not a foot, actually, it's a solder bump. Maybe one it's taller than another one. So it's not
Right.
even. You're handling maybe 100 like bumpers. They have like a distribution of height. So
Right.
that's you need to simulate how you to come up
So
with
you're saying the
something.
profile may vary considerably.
Yeah.
But so if that is the case, is that out of manufacture? Or because obviously if it's too if that happens too much, then you're going to lift the signal pads off the signal legs off the pads, aren't you?
Yeah, I'm not talking about the lead frame. I'm talking about the solder referral, the solder the volume of solder.
The volume of solder you put down, depending on the right. Yes, for sure.
There's a variation of volume of solder. So
And
after you
and obviously the actual metal frame is a separate piece to the pins, obviously, isn't it? So you're probably your metal frame is probably gonna be slightly higher above the PCB than the legs,
Yeah.
I guess. So you make sure the legs mate cleanly, and then the solder fills the gap to the metal frame.
the solder footprint will be larger than our lead frame. So the solder will be on the top of our lead frame after reflow.
Right.
Yeah. And we cannot really precisely control that.
Right. So this is what we were. So this is all part of the frame. So that this is where we're coming in here, where we wanted the right and left. So yeah, okay. So but what you're saying then is, in fact, if I just hide this a minute, where's that stiffening plate? If I hide the stiffening plate, so looks like we've put your connectors down. So what you're saying here is that, in fact, let me just lift this one up. Oops. Oh, this isn't the connector. This is a through hole one. That was what Ben did to. He made it surface mount itself. Okay. All right. I need to go back into the other model. But that's, for some reason these are huge models. They take ages to open. All right. So, all right. I get the point. I get the point. So the only other thing I was going to say was back on that other model, actually. Obviously, oh, that was quick. That worked well. So I guess if somebody does yank one of these cables left or right, if you pull on it, you'll get a tilting force on the connector, right? So, so if somebody's pulling the cable that direction, or whichever way it goes, this direction, it's going to tilt a certain amount before it tears it off the board, one assumes, right?
A little bit.
Are we talking a millimeter before it tears it off the board, or
Oh, way less than that.
way less? So you'd say like a fraction of a millimeter
Yeah.
before it tears. I'm on it about at the top here. Obviously, at the bottom, you've got the momentum of the height of the connector, right? So, or the moment of the height of the connector.
Yeah.
So you think you think, how much do you think it would move before it would tear it off?
I don't have a good feel for that.
Yeah. So what I was wondering is if our stiffener is wrapping around this.
I still think the tolerances are not available to us to do that.
Not available, right? No. And plus we can't wrap around it too much anyway, because you got the body of the cable plugging in.
You got to plug the cable in the top, and we're going to yank on it when we do the bend. or,
Yeah.
you know,
Okay. The only other thing I've seen is actually people epoxy these things down once they're, but that's another process step in the manufacture.
nobody wants glue in their factory.
Right. Yeah. Okay. So in terms of the viability of this, what if we go surface mount, is there any sort of stress test we can do of what force would tear these things off?
I'm sure there's a test for that. And Ariel, I need help from you on that.
Yeah, there is a test that we can do to determine how much force it would take to tear off that SMT connector in general. Yeah.
And can we sort of assess whether that just means it's not viable or you know, given, I guess in our situation, the manufacturing of this should be done in these topologies will be assembled in the factory. This isn't a customer. This isn't somebody at home plugging into an MCIO. This will be at manufacture time. So to that extent, I guess you could say there's more careful assembly than your average Joe buying a motherboard up or somewhere, popping it in.
Yes and no.
Yeah, I guess on these manufacturing lines, you get your average Joe a lot as well.
Yeah.
All right, guys. Okay, well, we're almost at the top of the hour. I'm glad we had the discussion. I'm not sure I'm much further forward.
Yeah, we have a better understanding. I think all of us do.
Yeah. All right, guys. Let me sleep on it and see where we take it from here.
Okay.
Well, thank you very much.
Thanks, Alan. Thanks,
Great.
everybody.
Thank you, guys.
Okay. Thanks,
Yeah.
Steve.
All right. Thank you.